In this video, we're going to talk about 3.4 Objective 3, where we interpret potentially misleading graphs. To explain how a graph that shows percentage change can show descending bars on a descending line, even when the variable of interest is increasing. If the vertical axis on the graph represents a percent change, such that the drop off means only that the actual value of the variable rises by smaller amounts. So an example of this in real life is if you're talking about inflation rates and the inflation rate goes down on the graph from, say, 6% to 4%. 6% would be super high inflation, but I'm just making this up, right? So if you were up here at 6% and you went down to 4%, it's still inflation. It's still a positive rate of change. That means that the price of goods and everything is still rising year over year. It's just rising at a slower rate. So don't see that this fact that it's going down, maybe it's going down then to 3.5%, and then maybe to 2.9%, which is somewhere that's regular inflation, right? But all the while, even if you're getting down to this 2.93% range here, it is still prices increasing year over year. It's still a positive rate of change. Okay. So let's determine whether the statement below makes sense or does not make sense and explain clearly. I drew a map on which I scaled the lengths from east to west of different countries representing area based on their numbers of family-owned farms, and found that a country with twice as many farms as another ended up looking 4 times as large. So that doesn't make sense since the map is only scaled in one direction horizontally. The size of each country is directly proportional to the number of family-owned farms. If you had scaled it in both directions, then 2 times 2 would be 4, and you would have this expected issue that we talked about with the dollar bill in the beginning of chapter 3, where they had scaled both the length and the width and gotten the issue with that. But that wouldn't happen here if we only changed one dimension. All right. Decide whether the following statement makes sense or is clearly true, or does not make sense or is clearly false, and explain your reasoning. There's been only a very slight rise in our stock price over the past few months, but I wanted to make it look dramatic. So I started the vertical scale from the lowest price rather than from 0. The statement makes sense because reducing the range of the vertical axis to just fit the data will increase the relative size of the variation in the data. We talked about that earlier, that's one of the tricks that people play when making graphs, is that they don't show the y-axis between 0 and the bottom of the area in which they're interested in showing you. And it leads to misleading interpretations about the percent change and so on. The accompanying figure shows the percentage change in the consumer price index, CPI, over recent years. end of year 12-month percentage change, overall items for a certain country, complete parts A through D. So this is exactly inflation that I was talking about. So the change in the percent change from previous year. So this is a rate of change. This is a percent change. This is inflation, is what we're talking about. We only see 1 year here with a negative percent change. There's some deflation going on there in 2015. But for all the other years here, we see inflation, which means that on average, year over year, your currency, your I'll just say dollar because we use dollars in the United States. Your dollar will buy less next year than it could buy this year. That's what these green bars mean. This red bar means that your dollar buys more than and is more powerful than in the previous year. So, and what year of the years displayed was the change in CPI the greatest? And that was in 2011, right here. And what year of those displayed was the actual CPI the highest? And how do you know? So the actual CPI was highest in 2020, and it's because there's been a positive change year over year, except right here. So if you're going up and up and up and up, you go down a little bit, and then you're going up and up and up and up, that this number at the end is going to be the highest number. So the actual highest CPI includes the change from all the previous years. That's what I'm saying here. So that blank is right here. And then briefly explain the meaning of the red bar in 2015. So the CPI decreased in 2015. If you were to graph the actual CPI between 2012 and 2017, would the graph trend upward or downward? It would trend upward, most definitely. I kind of drew a depiction of that here. And because most of the bars of most or all of the bar heights are greater than 0. So because you have all the green bars up here that are positive numbers, we have an overall positive rate of change. This little negative rate of change right here by like 0.5% or whatever is insignificant compared to all these green bars that are making it grow up. Go up. It's this little blip down here where it comes down just a little bit and then it just shoots right back up. All right. Let's look at number 5. The graph of the figure shows data in the relative risk of schizophrenia among people born in different months, complete parts A and B. So this is a special type of graph that shows your point estimate and how sure you are of that estimate. So with a margin of error. So this is basically a confidence interval that we talked about previously, and these are all confidence intervals. Then we can kind of see the trend here But the smaller these, the closer these bars are to the point estimate, that's the pink dot, then the more confident we are that of being close to that, the less air we have, let's say, in our measurement. So I shouldn't say the more confident we are, but the less air we have in our measurement. So let's go ahead and answer these questions here. Note that the scale on the vertical axis does not include zero. Sketch the same risk curve using an axis that does include zero. So yeah, they didn't include zero. They started at 0.6. There's some space here that they didn't include correctly. So our first data point here, this blue dot, is about at 1. So which of these has the first dot at 1 and then goes up, up, down, like so, and has the same kind of wave pattern to it? It's this one. It's C. It may be hard to see that it's C, but it is C. You'd have to go point by point and make sure that the bars here and the data point and the point estimates all matched each other. So comment on the effect of the change. The changes look smaller in the new graph. Each value of the relative risk is shown with a dot at its most likely value with an error bar indicating the range in which the data value probably lies. Again, this is a confidence interval. We're just not using that language right here, but we used that earlier in previous videos, so we might as well use it here. The study concludes that the risk was also significantly associated with the month of birth. Given the size of the error bars, does the claim appear to be justified? The question here, is it possible to draw a flat line that passes through all of the error bars so that, and yeah, right about here, right? So we could do that. And so yes, because we can do that, then the claim, it does not appear to be justified. That we see these points going up and down with the months, but they may not really be a significant change because we have so many of these lines here that we could pick, that we could draw right there, and they're within the margin of error for everybody, and it looks like there's essentially no change. So that's what they wanted you to get out of that. And one more question here. With 1996 used as a reference here, the accompanying graph shows the federal minimum wage in the United States together with its purchasing power, which is adjusted for inflation. Summarize what the graph shows. So we have minimum wage increasing in blue, and then the purchasing power of those dollars in 1996 dollars, so they're adjusted for inflation, trending down for the most part, so that you're making more money, but that money that you're making is actually buying less stuff because the dollars that you're earning are worth less. if that makes sense. That's kind of what it's showing us, and that that's been a problem, a real problem, since right around 1997, where these lines crossed each other. But so the minimum wage has steadily increased since 1955. The purchasing power of the minimum wage has increased until the late 1960s. We see this trend right here where this purchasing power is going up, then decreased until the late 1980s, which is right over here, right? That we've got this downward trend, and then has been relatively stable, that it's going up and down, but it's staying relatively flat right here, until, and this data ends at 2015. So we can't talk about anything since then, but those are the trends that they want you to see here. So that would be A. But just understand that that's roughly what you're seeing here. So, all right, that is the last topic for chapter 3. So we will come back next time and we will talk about 4.1 objective 1. See you for the next video.